Hi everyone, welcome again. So here we have a motherboard that I'm going to fix in a real time with you here. Basically the problem for this motherboard is a no data problem. Means when we connect the adapter, the fan starts spinning about 5 seconds and then shut down, and also the LED becomes flashing. So let me connect the adapter and see this failure. So let's connect the adapter. The adapter is connected. So guys, pay attention to the fan. The fan becomes spinning to LED also. About maybe 5 seconds it will stop. Here the fan stops, the LED flashes. We can even count how many seconds. Okay, let's count how many seconds, guys. So we have the fan, we have the LED. Pay attention. I will wait until it stops. So here we go. Look guys, 2 3 4 5 6 7 8 9 10. Okay, 10. At 10 seconds the fan stops. Means what exactly? Means we have problem somewhere in the CPU circuit or PCH circuit, because I told you that when the fan spins about 5 seconds, 6, 10 or even more, 15, the problem is in S0 state, not in S5. If there is a problem, for example, in S5, meaning in the charge circuit or 3 volt, 5 volt circuit, the laptop will not come on, will not power on at all. The first thing is to do a visual inspection, because by doing a visual inspection and checking all components in the motherboard, you can spot the problem without using multimeter, without using other tools like the power supply, the thermal camera, the voltage injector, etc. Oh, do you see? A drifted diode. So guys, I find this diode by chance. This is why the visual inspection is very important. Okay, so here we have the problem. Nice. And by the way, this diode belongs to the CPU circuit. This is the back of CPU socket. Okay, so here we are in S0 state. Because it belongs to the CPU circuit, that's why the fan spin about 5 seconds, 6 seconds and then stop. Because we are in S0 state. So once I repair this diode, the fan will continue spinning without any problem. That's why, guys, I told you, the power state are very important. When the fan starts turning 3, 5, 6 seconds, etc., means you have problem in the CPU circuit, or it could be in RAM circuit, because we are in S0 state. But if you put the adapter and the laptop doesn't work at all, means you have problem in the charge circuit near the adapter, the power jack or the battery connector, or in 3 volt, 5 volt circuit. So guys, remember, when you have this kind of problem, the fan starts spinning and stops after 5 seconds, or when the LED, do you see this LED? When the LED flashes like this, means you have problem 90% in the CPU circuit like this kind. We have a drifted diode. So let me please put this diode back to its place and then check if the fan will work normally and also the LED stop flashing. So I will remove the adapter and then reconnect this diode to its place. Please, if you are serious about improving your repair skills, subscribe and hit the bell icon to be notified for future videos like this one. And to be part of our family, where I have over 1000 friends, you are very welcome. All links in the description. Also, you're gonna find in the description the link for a full article in my website about all what we have discussing in this video. Now the diode is connected, guys. Always make sure the cathode here, this white mark means the cathode. For this diode, we have over here the cathode. So always for diode, because it is polarized like electrolytic capacitor, you have to pay attention to the cathode and anode. Now let's recheck the motherboard. As I told you, the diode belongs to the CPU circuit. Even here we have the controller. This is the power IC for the CPU circuit, and this MOSFET also is for CPU circuit, so this diode belongs to CPU circuit. So let's recheck again. Normally the fan should spin normally. Also this LED should be on without flashing. So let's connect the power adapter. And let's see. I have the fan. Good. This is good. So we fixed the problem. So let me disconnect the adapter. So guys, we fixed the problem. That's why I told you always do not ignore the visual inspection. So please, once you get any motherboard, try to do a visual inspection for all components in the motherboard. Big component, smallest one, all components, because you can find, just like this problem, a very hidden simple problem. You can even not use the multimeter on anything, just the soldering iron, and you will fix the problem without no thermal camera, no voltage injector, no multimeter, nothing. Just your eyes and the soldering iron, and you will fix a very tough problem. So right now I will summarize for you this failure. When you get a motherboard and you put the power adapter, nothing happen. No light on LEDs, no spinning in the fan, nothing, means you have problem here in the power adapter circuit or in the charge IC circuit. It could be also here, guys, we have 3.3 volt, we have 3 volt, 5 volt circuit over here. Here also could be the cause of no power motherboard or dead motherboard. But when you get the fan spins and becomes start 3 seconds, 5 seconds, if it's 3, means you have problem with the RAM circuit, because the RAM is the first circuit that get the power. When it becomes 5, 6 seconds, 10 seconds, means you have problem with the CPU circuit or even the PCH. Okay guys, or the PCH, basically the CPU circuit and the PCH circuits are on the same place in the motherboard. So first let's connect the adapter, and then let's put the multimeter to 20 volt DC. So we're gonna check the voltages in this motherboard from the input until the end. Means we're gonna check the input voltages, the charge circuit, the RAM circuit, the CPU circuit, all circuits. So let's check the main voltage. Here we have the DC connector. We should find 19 volt here in the first pin and also in the second pin, as you can see, because always 2 pins hold 19 volt in the connector. The next voltage that we gonna check is 3.3 volts always and 5 volts always. So let's look for the 3 volt and 5 volt always circuit. We have no circuit over here, we have no coil, because we use coils to locate circuits. So let's see the other side of the motherboard. So let's check. Here we have 3 volt 5 volt circuit. Why? Because 3 volt 5 volt circuit, you're gonna always find 2 coils next to each other, and also we have 2 capacitors. So this is the first channel for 5 volt. We have capacitor, coil, 2 MOSFETs, and this is the second channel for 3 volt. Capacitor, inductor or coil, 2 MOSFETs. So let's check 3 volt and 5 volt. So let's check this first coil. We have 5 volt in the multimeter. The second coil we have 3.3 volt in the multimeter. You can also check this capacitor, you're gonna find 5 volts, and also this capacitor for 3 volt, you're gonna find here 3.3 volt. Please note that we check the voltages that is present once you connect the adapter without pressing the switch button or the on off button. So 3 volt and 5 volts are good. What is the next that we have to check? We should go and find the BIOS. So let's look for the BIOS. Here we have the BIOS, as you can see. So note that the BIOS size is always bigger than MOSFETs. Here we have MOSFETs, here we have BIOS. Do you see? Always the BIOS is bigger a little bit. For the BIOS, we have to find 3.3 volt in pin number 8. Okay? Without pressing the power button, if you connect just the adapter, you have to find 3.3 volt in pin number 8 of the BIOS. So here we have this dot, as you can see, and this white mark. We have here 2 BIOS chips. Here we have a white mark, and this dot means this is the pin number 1, 2, 3, 4, 5, 6, 7, 8. So we should find here 3.3 volt, as you can see. The same for this one. We have this dot, and this white mark means 1, 2, 3, 4, and here we have 8. Always the reading is in counterclockwise. So we gotta find here 3.3 volt. So 3.3 volt here in pin number 8 for this BIOS, and also 3.3 volts for this chip also. So good. What is the next power that we have to find in the motherboard without pressing the power button? So let's look for the switch button or the on off button. So let's see the other side of the motherboard. This is the on off button. We have to find 3.3 volt in one side of this button, as you can see. Let's check here. We have 3.3 volts. So without 3.3 volt in this button here, the laptop will not comes on, will not power on, even if you press this button. So please pay attention. Now we check all voltages that is present once you connect the adapter. Now let's check other voltages in all circuits of the motherboard. So when you press the power button, you're gonna find other secondary voltage. So let's go directly to RAM circuit. So when you press the power button, the first voltage that appears is for the RAM circuit. So the type of this RAM circuit is DDR3, as you can see. So the voltage for this RAM have to be 1.5 volts as a main voltage and 0.75 volts for VTT or for terminals. So let's check. So here we have this inductor, because this circuit is for 5 volt and 3 volt. We have this inductor next to the RAM. So let's check. We have to find 1.5 volts, as you can see in the multimeter, 1.5 volt. And what about the terminals or VTT? If we go here, I will show you a very easy way to find or to check the VTT for the RAM. This network resistors, do you see this network resistors? Over here, we can check if the VTT is present or not. We have 0.75 volt. All the network resistors should hold the VTT or the voltage for terminals, as you can see. Same for doors here, as you can see. So the VTT is good. You can also check the VTT in the control IC. This is the RAM control IC. If we check these two capacitors, we have to find the VTT 0.74 or 75, as you can see. So the 1.5 volt is good for the RAM, and also the VTT is good for this RAM. So the RAM voltage is good. We have another voltage for RAM. It is 1.8 volt. We can't find it in this coil. We have 1.8 volt. So please, I have a question here. What is the difference between the main voltage 1.5 volt and the VTT voltage here in the network resistor 0.75 volt and the 1.8 volt voltage for the RAM? I will explain you. So 1.5 volt is the main voltage, the working voltage. Without this voltage, the RAM cannot work. Okay, and this voltage for VTT or for terminals, it is the voltage for buses or for connections in order to transfer data. Okay, for communication between the RAM and the processor, it needs this voltage. We called it VTT, means terminal or termination. Okay, and this 1.8 volt here is for reading and writing the data. Without this voltage, the data cannot be read or write. Okay, so let's move on right now to the processor, one of the most important circuit in every laptop motherboard. Over here we have the processor and we have the PCH. So what is the voltage for the processor? So the voltage for the processor is always between 0.5 volt and 1.5 volt. Basically for the processor you can find more than one channel. So let's check, for example, this coil. We should find a voltage between 0.5 volt and 1.5 volt. So let's check. We have 0.78 volt. This is good. This is the VCC core. We can also find the same voltage in this inductor, 0.7677 volt, because so this processor has two inductors. Also you can check the voltage in these ceramic capacitors. As you can see the same voltage here, 0.79, 0.79, 0.78, 0.78, as you can see, because these capacitors are here to filter the voltage and to get a pure and exact voltage. We have here basically other coils. As you can see here, if we check this coil, we have 1.05 volts. For this one also we have 1.06 volt. Here guys, this voltage is for the PCH and also we called it the VCCP. Okay, so 1.05 volt is for VCCP. Okay, VCCP also is the same as the VTT for the RAM, 0.75 volt. So the VCCP here, 0.5 volts, is for termination. It is used for buses between the PCH and the processor. So good, that's good for the processor. What is next? So the next voltages. So if we go, guys, if we go here to the battery connection, we should find 3.3 volt 3 times. 3.3 volt 3 times means the charge circuit is good. Okay, means the SMB clock is good, SMB data and SMB temperature are good. So let's check. We have 1.1, 1.1, we have 3.3 volts, the second 3.3 volt, the third 3.3 volt. Okay, so here we have first 3.3 volt, the second here, this is basically for SMB data. Okay, SMB data means the SIO or the super IO using this voltage, it knows about the state of the battery. Is it charged 100% or 50% or 70%, etc. And the second 3.3 volt is for the clock. And the third 3.3 volt is for the temperature. The SIO control the battery temperature. If the battery temperature is increased, is not normal, the SIO will shut down the charging voltage for this battery. So what's next? Now we're gonna see some secondary voltage. For example, for USB connector, we have also to find here 5 volt. In the capacitor, we have 5 volt. This is the capacitor. You should always locate the capacitor. For the HDMI, this is HDMI connector. Here in this fuse, we have here F, we have to find 5 volts, as you can see. So this is the power for HDMI and for the USB connector. So for the fan, as you can see here, always the red probe, as you can see, is for the working voltage. For this fan, we have to find about 3.3 volt or 5 volt, depending on the speed of the fan. We have 3.3 volt, but it could be increased to 5 volts if the processor is overheated. And this yellow cable here is the control signal for the fan. If the CPU heat is increased, the voltage here also will be increased. So if we check this pin here, we have 1.6, but it could be 2 volt, it could be 2.5 volts if the heat of the processor is increased. And then we have the ground here. So in the other part, the same here, we have other USB connector. Always you gonna find a capacitor like this one. This is basically, we called it a tantalum capacitor. Here we have to find 5 volt. Here also we have to find 5 volts. So this is polarized capacitor, tantalum capacitors. So this is it, guys. Thank you very much. Please don't forget to like the video if you enjoyed this video, and of course share this video with other interested people like you. And for anyone who want to join me in my Patreon page, you are very welcome, where you will find other unique content, and of course where you can download a lot of schematics for free. So thank you very much, and see you in the next video.